Okay, good evening, everybody. This is the last video for the day. First three videos, I went through the Design for X presentation for the three PowerPoint presentations: DFMA1, the role of the designer; DFMA2, manufacturing process choice; and DFMA3, DFMA principles. You can find those all here with links to the videos. The videos are uploaded to the YouTube channel that I have, which you have links before, but I also put them in here so you can pull them up as you want, as you need to there. The homework review questions are also out for the Design for X. This is the final module. Please note that this is not covered in your textbook, so really primarily you're going to be using the lectures, the PowerPoints for the material here, and anything that you find Googling on the topic. There are some excellent resources on the Design for Manufacturing guidelines. So what I've done is I've collected a number of these Design for Manufacturing guidelines under casting, forging, machining, injection molding, sheet metal, welding, and then additive manufacturing. I use these in a number of my classes, so I had them readily available. So I posted them up here. So this is a good thing to look at to reference some of the content and to answer some of the questions that are asked in the review question. So you can find that information there. Then there's some videos here that I think you might find particularly interesting about design and manufacturing and how the two kind of fit together. But this last video is just a brief look at the final exam for this class. So the final exam is out. You can see it right here. This is the student view, so this is what you see. It's due May 14th, which is the day of our actual final exam, so I didn't change that. I did give you all day, so it's due at midnight, so you have all day to do it on up to May 14th. But hopefully you'll get started sooner than that. That's the whole reason why I put it out here. So let me just go briefly through the two questions that I want you to answer, okay? So I want you to put on the role of a designer that's working with a design team, okay, or a member of a design team. And I'm presenting a couple of different scenarios for you, okay? So the first scenario is given this set of chess pieces, okay? So this nice contemporary kind of artsy looking set of chess pieces. This is the design that you and your team have come up with, and now they want to get an idea of how they should proceed in terms of their market footprint. Do they want to go with a high production volume, low cost design product, or do they want to go with an executive market, low volume, high cost kind of product? And your job is to help them get some understanding so that they can answer that question. So here's what I'd like you to look at. So first of all, given these set of chess pieces, 1, 2, 3, 4, 5, 6, 7, 8, times 2 is 16, times 2 is 32. So each set is going to have 32 pieces on it of these different shapes. Pawn, knight, rook, queen, king, bishop. We're not including the game board in this, okay? So just the pieces right now. The pieces can be made of plastic, metal, or wood. And what I want you to look at are these two fundamental questions. First of all, I want you to discuss manufacturing alternatives for the two scenarios that are laid out. So if you end up doing the high production volume, low cost route, what are the manufacturing alternatives for that? What fits well with that high production, low cost kind of environment, including what kind of materials, right? Plastic, metal, or wood. And then contrast that with the executive market, low volume, high cost. How would the manufacturing or production of these pieces change? How would the material change? Okay, so that's the two scenarios that I want you to look at, and I would like for you to, and it says here in the second one, make a best recommendation for each scenario. So you can imagine that you're going to be making a presentation to your team when you're done with your analysis, and you're basically going to say, okay, guys, if we are going to go with the high production volume, low cost alternative, I recommend we go with this production process or this production process using this type of material. Or if we choose to go with the executive market, I recommend that we use these production processes or this production process and this material. So I would like for you to justify your answer, okay? Don't just say this is my recommendation, but I want you to justify your answer. This justification does not need to have any calculations or computations or anything like that, but you can go pretty in depth about this. I want you to think it through very carefully so that you can, like I said, justify your answer. So, you can imagine that your design team is going to ask you questions and you want to be able to answer them appropriately. Okay, so that's the first question. The second question is, I'm giving you this wrench design. Okay, so ignore the fact that this is actually a Stanley wrench, but let's just say, in fact, I found other wrenches that look just like this that aren't made by Stanley. So Stanley probably just engraves their name on it. This is probably a pretty standard wrench that you can buy and put your own name on it. So, but pretend that we designed this. You, as a member of the design team, this is the design that you guys came up with. Okay, this type of wrench with a metal frame and a bi-material plastic handle. So you can see the yellow is one type of plastic, the black is another type of plastic. It's a 12-inch adjustable wrench. What I'd like for you to do is to discuss the manufacturing alternatives, again, for these two scenarios. Mass market production, so let's say we're selling it at Home Depot and Menards, so we need to make a lot of these wrenches, versus the high-end market production values, Snap-on or Matco, where we're not selling so many, but the product has to be very robust, very strong, very high quality, and we're going to charge a lot of money for it. So again, kind of similar to what you're doing for the chess pieces, but this time with the wrench. I would like for you to look at the material options given the required strength and durability for each of the products in each of the production scenarios. So you can already imagine the quality, the strength, and the durability does not have to be as high in the Home Depot Menards scenario, provided that the cost is a reasonable cost. Okay, I think people would be willing to save money on the cost, and maybe they're not doing the most difficult kind of repair work, versus the high-end market production, like the Snap-on and Matco, where these are serious professionals using the tool every day. In lots of different scenarios. They want a high quality, they want a wrench that's going to last for a good length of time. They're paying a lot of money, and so they don't want to be breaking it very often. Okay. And then the third question here is what are the different production processes required to achieve the final product? Now, that's why I gave you this design, because the design is very concrete. It's very detailed here. You can see everything. You can see the shape, and kind of you can infer very accurately really what production processes are required to achieve this. Okay, so that's what I'd like for you to do. What are the different production processes required to achieve the final product as shown for each production scenario? Maybe there's a different metal. Maybe you use a secondary or a finishing or conditioning process for the high-end market that you don't use for the mass market production. So I'd like for you to discuss the secondary operations such as conditioning and finishing, in addition to the primary operations, as well as the assembly. Notice that this has to be assembled together. Okay, is there a way that we can assemble this using robots? Does it have to be hand assembled? Those scenarios. Again, this doesn't require calculations, but I do want you to be as detailed as possible, because in my mind, you're going to be making a presentation of this to your design team, and they want a good, solid answer so that they know which way to go, and they may be asking you questions. So that's the game that I want you to play as you're putting this out there. Now, I will say I didn't make any links, but I will say there are some videos on YouTube where you can see wrenches like this being produced, and I would recommend you watch those. I think it's going to give you a good alternative for how different types of wrenches are made, the low end versus the high end wrenches. I think that may be that may help you paint a clearer picture in your mind. Okay, so those are the two questions that I want you to address for the final exam. All right, I'm not putting a length on this, how long this paper needs to be, or how many things, because I'm going to leave that open to you. Obviously, I want detail. Detail is going to be rewarded much better than being very brief and not going into any detail at all. If you choose to put in figures, then that, is one thing, but I don't, I'm not going to make any explicit requirements that there are figures in this. I don't think you'll need calculations. We didn't do calculations for the whole class. This isn't really that type of class. So if you have any questions about the final exam, please feel free to email me. If I need to do other videos, I'll be more than happy to do that. If I need to do a live session, I can do that as well. But let's just say that this is open. Please don't wait until the end, close to May 14th, to get started on this. That's why I put it out there early, so you can get this off your list of things to do. All right, so good luck. Let me know if you have any questions, and hopefully I will see you soon. Bye.